Hello, my name is Mrs Kershaw and I'm one of the Science Directors with Outward Grange Academies Trust. Today's lesson we are going to look at ionic bonding. Our challenge is going to be able to draw dot and cross diagrams to represent ionic bonds, and our aspire is going to be to describe how ionic bonds are formed. First of all then, why do things react? Let's go back to the periodic table then and see what we can remember. The number along the top is the group number. We can remember that groups go up and that this will tell us how many electrons are in the outer shell of an atom. So, atoms with incomplete outer shells are unstable, and they become stable by either gaining or losing electrons. When this happens, the atom will have an unequal number of protons and electrons. This means it will have an overall charge. It's then no longer called an atom, it becomes an ion. So, ion, key definition, is a charged particle, can be positive or negative, and it is formed when atoms gain or lose electrons. Something we need to remember. Going back to our periodic table then, I'm sure in the past your teacher will have shown you how to draw the steps starting at aluminium, going down the periodic table, and that when we've drawn this step, the elements to the left of the step are all metals and the elements to the right of the step are all non-metals. An atom that loses one or more electrons forms a positive ion, and that means that elements from groups 1, 2 and 3 will lose electrons to gain full out of shells. When they do that, they will form positive ions. And again, you may have been shown in the past that you can write the charges of these ions on your periodic table. But the thing to remember is that metals form positive ions. So let's have a look at how they do this. A sodium atom then will have 11 protons and 11 electrons. Protons are positive, so it has a plus 11, and the electrons are negative, so it has a minus 11. If we add those up, overall we have zero charge. However, we have a partially full outer shell, and this means that the atom is unstable. The easiest thing for sodium to do then is to lose this one electron that it has in its outer shell. This now means that it has 11 protons still, because it's still sodium, and if we change the proton number we change the element. But now it only has 10 electrons because it's lost one, and if we add our charges up now we get a charge of plus 1. We tend to draw ions in square brackets and we put the charge outside of the square brackets. Here we can see that its outer shell is full and this ion is now happy. So now I would like you to use the same principle and show how a magnesium atom becomes a magnesium ion. And magnesium has 12 electrons. 1 minute, off you go. How did you get on then? So, red pen, correct it if you need to. Magnesium atom has 12 protons, a plus 12 charge, and 12 electrons, a minus 12 charge. Altogether that adds up to 0. And magnesium, because it's got 12 electrons, will have 2 electrons in its outer shell. Magnesium will lose these 2 electrons to form a stable ion. Now it still has 12 protons, but it now has 10 electrons, and that charge adds up to plus 2. So a magnesium ion will have a plus 2 charge. If you need to pause the video and correct your answer, do so now. An atom that gains 1 or more electrons forms a negative ion. It's gaining negativity. Elements from groups 5, 6 and 7 will gain electrons to get full outer shells. And if we go back to our periodic table, we can show our positive metal ions, and then non-metals form negative ions. So we've got -3, -2, -1. Group 4 do not form ions, and group 0 already have a full outer shell, so do not lose or gain electrons. Let's look at a fluorine atom then. Fluorine has 9 protons and 9 electrons. Overall it has a charge of 0, but it has a partially full outer shell with 7 electrons in its outer shell, so it's not happy. It therefore gains 1 electron, and now it has 9 protons and 10 electrons. When we add this up, this gives us a charge of -1. So when fluorine gains an electron, it forms a fluoride ion. Note the difference. As an atom, it's a fluorine atom, and as an ion, it's a fluoride ion. That's something to be careful of when you're writing about this. But now it has a full outer shell and a -1 charge. I would like you then to draw a diagram to show how an oxygen atom, which has 8 electrons, becomes an oxide ion. And again, just remember that negative ions change their names and end in "ide." 1 minute, off you go. Right, so if we look at an oxygen atom then, it had 8 protons and 8 electrons and an overall charge of 0. But it had a partially full shell with only 6 electrons in it. It gains 2 electrons, and now it has 8 protons and 10 electrons, which gives it an overall charge of -2. So an oxide ion will have a -2 charge. But that's not the whole story. We've talked about atoms gaining and losing electrons, but you can't just find electrons and you can't just lose them. So it needs 2 elements to react together, and in the case of ionic bonding, it will be a metal reacting with a non-metal. The metal will lose electrons and the non-metal will gain electrons. This then produces two oppositely charged ions, and they become electrostatically attracted to each other and form an ionic bond. This will also produce a compound. First of all, let's look at the bonding in sodium chloride. When we have a sodium atom and a chlorine atom, the sodium atom has 1 electron in its outer shell, and the chlorine atom has 7 electrons in its outer shell. Here it's quite straightforward. Sodium wishes to lose 1 electron and chlorine wishes to gain 1 electron. So the outer electron from sodium is transferred to chlorine. We now have a sodium ion and a chloride ion. The sodium ion is positively charged and the chloride ion is negatively charged. These oppositely charged ions would attract each other through the electrostatic force of attraction between the oppositely charged ions. This is the ionic bond. Ions, however, are not two-dimensional. They exist in all 3 dimensions. So the positive and negative charge will be applied in all 3 dimensions. Ionic compounds will consist of more than 1,000 ions, and these are joined together by ionic bonding to form a 3D lattice. Let's now have a look at magnesium oxide then. So as you'll know from your periodic table, magnesium is in group 2, so it has 2 electrons in its outer shell, and oxygen is in group 6, so it has 6 electrons in its outer shell. So here we have magnesium, which wishes to lose 2 electrons, and oxygen, which needs 2 electrons to gain a full outer shell. So in this case, 2 electrons are transferred from magnesium to the oxygen. This will leave the magnesium ion with a +2 charge, and the oxygen atom has now gained 2 electrons and becomes an oxide ion that has a -2 charge. And just in the same way that sodium and chlorine reacted, here we've got the magnesium ion and the oxide ion that are oppositely attracted. So the electrostatic force of attraction between the oppositely charged ions occurs, forming the ionic bond. And in exactly the same way as the sodium chloride, these ions are 3-dimensional, and this will happen in all 3 dimensions, forming a giant 3D lattice. So going back to sodium and chlorine, the sodium loses its outer electron and chlorine gains it. The result is that both of the elements end up with full shells and become ions. These ions are oppositely charged, so the 2 oppositely charged ions that are formed attract each other, and the ionic bond is the electrostatic attraction between oppositely charged ions. Now, whenever anything bonds, it will always be due to electrostatic force of attraction. There are 3 types of bonding: ionic bonding that we're looking at today, and there is also covalent bonding and metallic bonding, which we'll look at in later lessons. But for each of them, the bond is always an electrostatic force of attraction. In the case of ionic bonding, then the electrostatic force of attraction is between 2 oppositely charged ions. It might be worthwhile at this point pausing the video and copying down this summary sheet, and then in each of the bonding lessons we will refer back to this and you'll be able to build up a revision poster for bonding. Right, now I would like you to draw dot and cross diagrams to show how these pairs of atoms will react. So how will sodium react with fluorine? How will lithium react with oxygen? And how will aluminium react with fluorine? The way to do this is in the first instance to draw the atoms, then to show the electron transfer, draw the ions, and then describe what has happened. I'm going to give you 5 minutes to do this. Okay, so take your red pen and let's see how you got on. So with sodium and fluorine, the sodium loses its outer electron and the fluorine gains it. The reason that we draw these as dots and crosses is because then it becomes very easier for the examiner or somebody marking your work to be able to identify the electron transfer. The bond then will be between the positively charged sodium and the negatively charged fluoride ion. In both cases, the ions have 8 electrons in their outer shell. If you need to correct your work, pause the video and use a red pen. Lithium oxide is a little bit more complicated because it's not a straight transfer between two atoms. So in this case, oxygen needs to gain 2 electrons, but lithium only wants to lose 1. So what happens in this case is 2 lithiums will react with the oxygen, each donating 1 electron. That then results in 2 positively charged lithium ions and 1 negatively charged oxide ion. You'll see the formula for lithium oxide, Li2O, and this reflects the fact that 2 lithium atoms have each donated an electron to 1 oxygen atom. In aluminium, fluoride is the non-metal atom that we need more of. So aluminium has 3 electrons in its outer shell that it wants to lose. But if it's reacting with fluorine, fluorine only wants to gain 1 electron. So in this case, aluminium will donate 1 electron to each of 3 fluorine atoms. That results in us producing 3 fluoride ions and 1 aluminium ion. The oppositely charged ions will then still attract and form aluminium fluoride. Right, time for you to have a go then. So 4 marks, 4 minutes. The diagram shows an atom of magnesium and an atom of chlorine. Describe in terms of electrons how magnesium atoms and chlorine atoms change into ions to produce magnesium chloride. This is a describe question, so you'd need to say what you would see happening. We underline the keywords. It wants you to be talking about electrons. And then glancing back over the question, we're looking at magnesium atoms and chlorine atoms. 4 minutes, off you go. Okay, so grab a red pen and let's mark this question. So if you said that magnesium lost electrons, you gained 1 mark. If you said magnesium lost 2 electrons, you get that 2nd mark. If you said that chlorine needed to gain electrons, you gained 1 mark. And if you recognise that it would be 2 atoms of chlorine, each gaining 1 electron, then you got that 4th mark. Now, there are many ways in which you can lose marks in this type of question. One of which would be to start talking about chlorine ions. You wouldn't get any marks for that. And it's far easier if you draw what is happening. So examiners, if you drew this diagram, would give you all 4 marks because you've clearly shown that magnesium's losing electrons, the chlorine's gaining electrons, you've shown the ions that are formed, and you've shown that it's 2 chloride ions and 1 magnesium atom. So rather than tying yourself in knots with lots and lots of words, simple diagram would straight away get you 4 marks. Okay, well done. That's the end of the lesson on ionic bonding. You should now be able to describe how ionic bonds are formed. If you wish to record more detailed notes in your book, then these occur on the following slides. Pause the video as you need to.